Okay, so in your quiz 1, so in consolidation, we have this problem. The soil profile at the site consists of 2 meters of sand at the ground level, underlain by 6 meters of clay, followed by a very steep clay stratum that can be assumed to be impervious and incompressible. Okay, the water table is at 1.5 meters below the ground level, so the moist saturated unit weight is 17 and 18.5 respectively. And the clay has initial void ratio of 0.81, saturated unit weight of 19, and coefficient of consolidation to be 0.0014 square centimeters per second. When the ground is surcharged with a 3-meter high compacted field with a moist unit weight of 19 kilonewton per cubic meter, the settlement was 160 millimeters in the first year. And what would be the consolidation settlement in the first 2 years? Then we have these choices. Okay, so the problem is asking what is the expected consolidation settlement in the first 2 years. Okay, and we are given that sabi dito, we are given that in the first year we have 160 millimeter settlement. Okay, the problem is not saying that at first year we are completed the primary settlement. Okay, so therefore we cannot assume that at first year we completed or the soil completed the primary settlement. Okay, so we are assuming that we are guaranteed that the 160 millimeter in the first year is not yet completed the primary settlement, and also the second year. Okay, since the problem is not stating that it was completed. Okay, so therefore, we need to determine the complete primary settlement in the problem. Okay, so before we start, so draw muna natin yung problem. Okay, sabi niya, the soil profile consists of 2 meters of sand. So this is 2 meters. And this is underlain by 6 meters of clay. Then this is let's say this is bedrock. Okay. Then the water table is 1.5 meters from the ground level. So this is 1.5. Therefore, this is 0.5. Okay. And this is 6 meters. This is clay, this is sand, and this is sand. Okay. And the moist unit weight of our sand is 17 and 18.5. So therefore we have this 17. We have this 18.5. And for the clay we have 19 kilonewton per cubic meter with a coefficient of consolidation to be 0.0014. And initial void ratio, or E sub 0, we call it 0.81. Okay. Therefore, to solve for this problem, we need to determine muna natin yung sigma prime O, or at the effective stress at the middle of the clay. So that is 17 times 5 is 17. I think hindi na rin siya necessary. Okay, however, problem A is asking what is settlement after 2 years. Okay, so since we are given that first year we have 160 millimeter settlement, so Therefore, we need to find first the time factor for 1 year. What is the TB for 1 year settlement? O yung time factor na kinonsider doon, since we are given the coefficient of consolidation. So the formula is TV is equals to CV times the time it takes. Then you have your HDR squared. So we need to determine what is degree of consolidation in the first year. So we need to find what the degree of consolidation in the first year. So in order to find the degree of consolidation in the first year, we need to find the time factor, since the time factor is have a relation to the degree of consolidation. Okay, so in order to find the TV, so TV is equals to 0.0014, since this is centimeter and seconds. So therefore, your 1 year is 365 times 24 times 3,600. Okay, for hours to seconds. Then you have this HDR. According to the problem, we have bedrock impermeable layer at the bottom. So therefore, our drainage is only 1. So therefore, we have 6 meters. Okay. However, this is centimeter. So therefore, we need to convert our 6 meters to centimeters. So that is 600 squared. Okay, therefore, your time factor is equals to 0.123. So you need to determine what is the degree of consolidation. Okay, what is the degree of consolidation at that time factor? Okay. So ano ba yung degree of consolidation at that time factor 0.123? Okay, so first, pwede mong i-check by using the table, or you can use the formula. So ako gagamitin ko yung formula. So I will be using the formula. So let's say we assume U is less than 60%. So therefore, our TV is equals to pi over 4 U squared, which is equals to 0.123 equals to pi over 4. What is your U squared? Therefore, your U is equals to 39.57%, which is, our assumption is correct since this is 60%. Therefore, assumptions is okay. Okay, then so since we know the degree of consolidation of 160 millimeter settlement in the first year, so we can determine that the total primary consolidation. Okay, so what is other definition of degree of consolidation? That is okay, so that is ST over SP. Yeah, I'm sorry, it should be ST over SP. ST over SP. Or yung settlement at specific time. Lolo ko. Okay, so settlement at a specific time. Ano kaya? Over SP. Okay, therefore, your 39.57% is equals to SP. Then you have your specific ST, which is 160. Okay, so therefore, your SP is equals to okay, that is 404. Wait lang, naglolo ko talaga siya. 404.347. Okay. So next is we need to determine the degree of consolidation after 2 years. Okay. So what is the degree of consolidation after 2 years? So if you recall the relationship of time 1, time 2, and degree of consolidation, that is T1 over T2, U1, U2, then is squared. So since we know that time 1 is 1 year, this is 2 years. Okay, the degree of consolidation at the first year is 39.57. And we need to determine the degree of consolidation after second year. Okay, therefore, this is U2 is equals to 55.96%. Therefore, your ST at 2 years is equals to 404.347 multiplied by 55.96%. That is equals to 226.272 millimeters, which is exactly letter C. Okay, so that is how you solve this problem. So you cannot assume, again, you cannot assume that at the first year that is the complete settlement or the complete primary settlement. So you cannot use secondary consolidation assumption for second year. Okay, so therefore using this time rate of consolidation formulas, we are able to determine the time settlement or the settlement at 2 years. Okay, so do you have any questions? Okay, so ito lang naman yung problem na hindi na-solve ng karamihan. Okay, so okay. So so today we are discussing subsurface exploration and some NSCP 2015 provisions for the subsurface exploration. Okay. For the subsoil exploration, so the purpose of the subsoil exploration includes the following. Okay, number one, we need to determine the nature of the soil at the site and its stratification. We need to obtain the disturbed and undisturbed soil samples. Okay, we need to determine the depth of the nature of the bedrock if we are encountered. Okay, number four, we need to perform in situ field tests. Okay, we need to observe the drainage conditions. Okay, we need to assess any special construction problem. Let's say, for example, the you have your plastic soils, liquefiable soils, okay, and determine the position of the water table. So that is the purpose of the subsoil exploration. Okay, so we need to plan for subsoil exploration. Okay, number one, we need to compilation of the existing information regarding the structure. Okay, so yung compilation or yung past data, okay, let's say what type of structure that we are constructing, what is the use of the structure, ano yung local building codes na gagamitin natin. If we are, if your project is in Japan, syempre you will be using the Japanese code or Japanese building code. If you're in Europe, you will use the Euro code. Okay, if your project is in the Philippines, okay, you will be using the national structural code of the Philippines. Okay. And also, you need to consider the column and load-bearing wall loads. Okay, so that is the compilation of existing information. Number 2 is the collection of existing information of the subsoil condition. Okay, so as if you are a geotechnical engineer, okay, so you will need to review the existing information regarding the soil conditions under the site. Okay, so you need to check the geological survey maps. Okay, you need to determine the country soil survey maps. So in the country of United States, so there is a geological survey maps, or they have this soil survey maps. Okay. Then we also have the soil manual published by the State Highway Department. So we have the soil manual. So if you check your your DPD the blue book, yung DPWH manual. So we have this one. And we have this existing soil exploration reports prepared for the construction of nearby structure. So for example, at this is your site, and yung isang nearby project, this one, they determine that the soil is liquefiable, or the soil is plastics. Okay, your soil is plastic. So we can assume that our soil, since it is a nearby site, our soil in our site is somewhat like or the same to this site. Okay, so you need to check the existing soil exploration reports. Okay, so if you are able to get the access for the nearby structures. Okay, number 3, we need the recognize of the proposed construction site. So what is the type of vegetation at the site? The accessibility of a site and the nature of drainage. Okay, then you need to open cuts near the site, provide an indication about the site soil stratification. Okay, and this one is very important. If you determine cracks in the walls of the nearby structures, okay, you need this will indicate settlement from the possible existence of the soft clay layers or the presence of expansive clay soils. Okay, and number 2, evidence and of landslide or stability problems. If the nearby construction site or the nearby constructions or buildings has an evidence of landslide and a problem for slope stability of the soil. Okay, so you need to consider this one. Okay. Then lastly, we have this detailed site investigation. So for the detailed site investigation, the phase consists of making several tests. Okay, test borings, okay, this one, at the site, and collecting disturbed and undisturbed soil samples. So it was derived from different depths, and for visual observation and for laboratory tests. So we have these different laboratory tests. So you need to use test borings, then soil sampling, okay, then groundwater monitoring, then exploratory trenches. Okay, then you need to solve for this detailed site investigation. So ito lahat yung kalimitang kinukuha for the geotechnical report. The natural moisture content, the Atterberg's limit, we have the liquid limit, plastic limit, shrinkage limit, the specific gravity of your soil unit weight, your grain size analysis, your soil classification, the California bearing ratio. If your soil is resting on, if the design of your ground floor slab, okay, if the design of your ground floor slab is not suspended, you need to check this California bearing ratio. So yung California bearing ratio, so let's say this is your slab at the ground floor level, then this is yung soil. If you are assuming that the soil will help your soil will be the support for your ground floor slab. Okay, you need to check this California regulation. Then again, the compaction test. So we have this compaction test, 95% of the MDD. Okay. Then we also have this shear strength for direct shear test, triaxial shear test, unconfined compressive strength. And we have this consolidation test. Okay, so all of these laboratory tests will the geotechnical engineer need to investigate, okay, in order for structural engineers to solve for the foundation solutions and different design problems. Okay, so for the depth of exploration, so since let's say for example ito yung soil natin, so paano ba natin ma-determine kung hanggang saan tayo kukuha ng soil sample? So let's say magbo-boring tayo. Okay, this one, then magbo-boring tayo, kukuha tayo ng soil. Okay. Okay, this one. So ano ba yung depth nito? Okay, ano ba yung depth of exploration we need to consider for getting the soil sample? So generally, the soil exploration should be advanced to a depth up to which the increase in pressure due to the structural loading will have no damaging effect. Okay, so that is the thumb rule or the general rule in determining the depth of exploration. If the increase in pressure due to that structural loading will have a no damaging effect on the structure. So in other words, the depth at which the soil does not contribute the settlement of the foundation. So this depth is termed as to be the significant depth. Okay. Then we also have these various factors affecting the significant depth are as follow. Number one, we have this type of structure. Okay. So what syempre, if your structure is let's say you have a 3 floors basement at you have 3 floors basement and your significant depth is let's say 6 meters. Okay, let's say lang 6 meters. So ibig sabihin, you have your basement na let's say yung basement mo for 3 floors is H below is 9 meters and your depth of exploration is 6 meters, which is not okay since mas mababa pa yung height of the building. So you need to consider this type of structure. Okay, next to consider is the weight of the structure. For the weight of the structure, syempre, that weight of the structure is the induced pressure at the top of the soil. Okay, this is the weight of the structure. So you need to consider this weight of the structure since the weight of the structure is affecting the effective stress of our soil. Okay. Next one is the dimension of the structure. Okay, so the dimension of the structure tell us how many boring samples, okay, we need to consider in getting the soil samples. Okay, so for example, you have this site. Okay, how many test bore yung kailangan natin for this, let's say this 10,000 square meter building footprint, site building footprint. Okay, so we have this provision later, NSCP provisions for how many test bore yung kailangan mo for a specific building footprint area. Okay, then we have this disposition of the loaded area and the soil profile and the layer of properties. Okay, so there are following 3 thumb rules that can be used to know the significant depth. Number 1, okay, is the depth where the net increase in the vertical pressure becomes less than 10% of the initial overburden pressure. Okay, so that is why you need to consider the weight of the structure. So we need to consider the weight of the structure in order for us to determine the significant depth. Okay, number 2, thumb rule is the maximum depth reached by the pressure bulb or this isobar diagram. So this is a isobar diagram or the stress zone of the isobar. It was drawn with an intensity pressure varying from 1/5 or 1/10 of the surface loading intensity. Okay, so let's say you have this load Q. Okay, this linear uniform load per linear meter Q. Okay, so this is this comes from the weight of the building. Okay, and yung cut, yung slope. Okay, so this is Q. Then you need to draw this loading intensity. Let's say for example you use 0.2 Q. So ginamit mo yung 0.2 Q. Where Q is the initial loading intensity. Then you draw this isobar pressure bulb. Okay. Then the diameter of that isobar is approximately 1.5 B. Okay, so it may be equal to 1.5 or to 2 times the depth of the smaller dimensions of the loaded area. So this is the significant depth. So we can use 1.5 B to B. Let's say you have this building footprint 5 meters and 10 meters. 5 meters. Sorry, masyadong maliit. So let's say 50 meters, ano na lang. There's 50 meters and 100 meters. So therefore, we use B to be 50 meters since that is the smaller lateral dimensions. And we can say that our depth of exploration or the significant depth is approximately equal to 75 meters to 100 meters. So ganyan kahaba yung soil investigate mo na soil samples, yung kukunin mong soil sample in your test boring. Okay, so this one test boring. If nakakita na ba kayo ng nagte-test boring? Okay, this one. So approximately you need to use 75 meters to 100 meters. In our example only, this one is for our example only. So this is the general rule, which this one 1.5B to 2B. So if you want to be a geotechnical engineer, according to them, they are using this thumb rule and this thumb rule. Okay, so it can be used as this thumb rule 1 and this thumb rule 3. Okay, so ayan. So we have these thumb rules can be used for the significant depth. So let's say for this one, we have this isolated footing. We have this 1.5B. Adjacent footing with clear spacing less than 2B, we have this 1.5L. Okay. So for pile foundations, typically we have 10 meters to 30 meters depending on the length of the piles with, based on the design. Or they can use the 1.5B. Okay, then based on retaining wall, they can also use 1.5B or 1.5H. Exposed height of the wall face. Pag, if you have this retaining wall, let's say this one, and you have this retaining wall, the exposed height is this one. So ito yung retaining wall. Okay. The exposed height is this H. So for the depth exploration, you need to use 1.5H or 1.5B, whichever gives you the larger number that is your governing depth, significant depth. Okay, the floating basement, we have this depth of construction. For dams, they use 2 times the height of the stream to the crest for concrete dams, or maybe they use up to the bedrock if they have enough funds up to the bedrock in all soft and unstable permeable strata. For the roads cuts, for the roads they are just using 1 meter trenches or in cut sections 1 meter below the formation level. So for that is the roads. And for the road fill, typically they are exploring 2 meters below the ground level or equal to the height of the fill, whichever is greater. Okay. So there are different methods of exploration. So number one, we have this open excavations. Okay, so open excavation is basically what is ano yung ginagawa dun sa mga small buildings. Okay, so they have these trial pits and they have these trenches. So this one is the trial pits and this one is for the trenches. So trial pits are applicable to all types of soil, which provides visual inspection of the soil in their natural conditions in either disturbed or undisturbed state. And here, the depth of investigation is limited to the 3 to 3.5 meters. So there are two ways, again, for open excavation. We have this pits and trenches. Okay, so pits and trenches is a very good methods of exploration if you want to provide visual inspection of the soil. So you have this preliminary investigation, just take pits and trenches. Then number two is we have these drifts and shafts. Okay, so drifts and shafts is this one. So this is drift. So parang gagawa kayo ng tunnels, and this is shaft. Okay. This one is for the drifts and this one is for shafts. And next is the boring. Okay, this one is widely used subsurface explorations. Okay, the boring methods. Okay, boring methods are widely used for the subsurface investigation to collect samples. So in almost all types of soil for visual inspection or laboratory testing, there are several boring techniques that we can use. We have this auger boring or auger boring. We have this rotary drilling. We have this washboarding. We have this percussion drilling and auger drilling. Okay, this type of boring techniques are employed to collect the disturbed and undisturbed sample of the soils. Okay, the first of the several boring techniques is the auger boring. So it is simple and cost-effective boring techniques which can be used for almost all types of soil apart from gravelly soil rocks. Okay, so auger boring method uses this manual drilling or manual boring. Okay, so it is used to collect disturbed soil specimen. So it collects the soil sample from a maximum practical depth of nearly 35 meters based on the available time and the equipment type. Okay, so you have this auger boring. Then also we have this rotary drilling. So rotary drilling method is suitable for all types of soil, including the rocks. So it is used to take disturbed as well as the undisturbed soil sample. So it is specifically applicable for very steep soil layers. Okay, the practical depth of sampling is around 270 meters and greater depth based on the type of the specimen to be used. For the rotary drilling, so we have this engine and transmission box. Then they have this pump. Okay, so basically they are using the equipment for drilling the soil sample. This is rotary drilling. Okay, next one is the washboarding. So this washboarding is used to collect disturbed and undisturbed samples. Again, in almost all types of soil except for the rocks. So in this technique, portable, cheap, and limited equipment is used which is an advantage of the washboarding. So that is why kapag nakakita kayo ng mga geotechnical investigation dito sa Pilipinas, okay, they are using this washboarding. So kung nakakita na kayo laging may umaapaw dyan na tubig, may lumalabas na tubig dun sa sample nila. So yan, laging basa yan, may lumalabas na tubig dyan. So they are using this washboarding. Okay, since this washboarding is very cheap, okay, and they just need to use ordinary equipment. Let's say this one is very small horsepower lang. Ito ay ginagamit to sa mga farming. Okay, so kapag magpa-pump ka ng farm or mga di ba sa farming dito sa Philippines, okay, this one. So they are just using this equipment to help them take samples. Okay, similar again, this is similar to rotary drilling. So they are using these thin-walled tube samplers and piston samplers to recover the undisturbed soil samples with a minimum of 50 millimeter diameter and a maximum of 100 millimeter diameter. Okay, then they also have this percussion drilling. So percussion drilling means they are vibrating the soil sample to get the soil specimen. So it is used for all types of soils and rocks. Okay, again, this time they can use this percussion drilling to get the stiff soils and rocks, to get the sample for stiff soils and rocks. Okay, percussion drilling is used to take undisturbed and undisturbed specimen, but the quality of the undisturbed samples is not that good because of the heavy blows of the chisel. Okay, so the vibration comes from the blows of the chisel. Okay, then how to determine the depth and the spacing of the boring. Okay, so the test boring should extend through unsuitable foundation materials to firm soil layers. Okay, so according to the equation given by Sowers, provided a rough estimate of the minimum depth of the boring unless bedrock is encountered. Okay, so depth of boring is different from the significant depth of the soil. Significant depth of the soil is used to determine what depth you need to consider in consider in the design phase. Okay, so you need to determine all the parameters in that significant depth. And then for the depth of the spacing or depth of the boring, the depth of the boring is used to get soil sample specimen. This depth of boring, so you need to para kang maglalagay ng additional soil sample. So mas hahabaan mo pa yung soil sample mo sa significant depth of your soil. Okay. So dapat the depth of the boring is always greater than or equal to the significant depth. Okay. So according to the formula given by Sowers, for light steel or narrow concrete buildings, they are using this equation C sub B, or the approximate depth of the boring is equals to 3 times the number of stories raised to 0.7. Okay. And for heavy steel or wide concrete buildings, they are using this depth of boring, okay, is equals to 6 times the number of stories raised to 0.7. Again, the significant depth, the depth of the boring should always be greater than or equal to the significant depth. Okay, so depth and for the spacing of the boring or the spacing of boring samples. Okay, so they are using this general spacing of borings. Okay, for one-story buildings, typically the spacing of the boring is 25 to 30 meters. Then for multi-story buildings, they use this 15 to 25 meters. For highways, okay, kung mapapansin nyo, highway medyo mahaba na yan. Okay, the spacing of borings is typically 250 to 300 meters. For dams, they use this 25 to 50 meters. And for residential subdivision planning, they are using the 60 to 100 meters. Okay, so this is the code provisions given by the NSCP 2015. Okay, so what is the minimum required number of boreholes? Okay, so if you check your table 303-1, the minimum required number of boreholes per structure. So the structural engineer, okay, the structural engineer sometimes sometimes gives the number of boreholes since the number of boreholes. Bakit si structural engineer yung magbibigay ng number of boreholes, hindi si geotechnical engineer? Okay? So pwede rin naman si geotechnical engineer magbigay, pero bakit dito lagi nauuna sa structural engineer? Because the client or the architect, let's say the client or architect gives the plan to the structural engineer. Okay? Then since the structural engineer let's say the structural engineer require a geotechnical report. So the structural engineer gives the number of boring sample and the spacing of the boring sample. Siya yung magbibigay dun sa geotechnical engineer. Kasi yung una, wala namang plano na binibigay dito sa geotechnical engineer. Okay? So again, the plans, take note of this one, are confidential. Okay? So, plans are very confidential and hindi ito binibigay basta-basta. Kapag hindi naman siya included sa construction throughout the project. So, the geotechnical engineer, hindi yan ibibigay yung plans. So, tanging si structural engineer lang ang muna ang makakakita ng plans. Okay? So, therefore, we, as structural engineer, will give the client or the architect the number of boreholes, and this client or architect will tell the geotechnical engineer how many boreholes required, minimum boreholes required, stated by the SE. Okay, so given this NSCP 2015, okay, the footprint area of the structure and for the minimum number of boreholes. For the footprint area of your structure that is less than 50 square meters, the minimum required number of boreholes is 1. Then for 50 to 500 square meter of footprint area, the minimum required number of boreholes is 2. And for any greater than 500 square meters, you need to use this formula. So how to use this formula? Okay, so basically ganito lang siya. For this one, let's say you have the 600 square meters. So therefore, you need 2 plus A over 1,000, which is equals to 2.6 over 6, 2.6, let's say. Okay, so 2.6 is approximately 3 boreholes. Okay, so that is this one. So for example, you have this, let's say, ito yung site building footprint mo. Okay, hindi kasama yung class yung mga kunyari meron kang tawag dito, you have this escalator sa labas or maybe you have this canopy sa labas, hindi nakasama yan, basta yung main building footprint lang. Okay, so for example, ito yung main building footprint mo. Okay, and let's say you have different buildings, so also have this one. Okay, yeah, so that is the building footprint. Okay, so you need to determine how many boreholes. So for example, this one, you need 3 boreholes. Okay, you have 3 boreholes, so maybe you can place the borehole at this location, then this location, Also this location. Okay, you need to consider this boring spacing. Okay, so what is the proposed location of the boreholes? So let's say, for example, you have this building. The general proposed location of the building is this one at each corner and one at the middle. So depending on the budget of the client, okay, the budget of the client, since this one is also is only a minimum required number of boreholes, so you can also propose this proposed location. Okay, so you need to increase. Let's say this one 3 ay kailangan gusto mo medyo mas marami kang samples, so mas para sure yung soil bearing capacity of the soil. So therefore you can use this general thumb rule which is one at each other and one at the middle. So for example, this one, you have this building footprint, so one at each corner, one at the building. Okay, then for power plants or integrated plant, okay, so they can treat each structure as a single unit. Okay, so take note for power plants and integrated plant, so bawat machine or bawat structure you need to consider as one single unit or one unit. Okay, so again, one in each corner, one in the middle. Then for dams, okay, so paano ba naglalagay ng location ng borehole sa dams? Okay, so for the location of boreholes in the dam, you need to determine, you need to get the soil sample or test boring in the water flow, okay, in the direction of the water and along along the structure or along sa dam structure mo. Okay, so upstream, downstream, along the dam axis, and left and right abutment. Okay, you have this left and right abutment. Okay, this one and this one. Okay, kung maglalagay kayo ng abutment dun sa dams. Okay, then for bridges, okay, for bridges, you have this one at each abutment and one at each pier. Okay, then for roads, okay, for roads, typically the test pit is 100 meters. Test pit, take note, the test pit is every 100 meters. And for boring sample or auger sample, they are using every 50 meters. Then they can also check the bridge guidelines. For slope soil, okay, if boreholes oriented parallel to the direction of the failure objective is to draw the cross section. Okay, so let's say this one, the objective is to draw the cross section. So for example, this is your slope soil. So you need to draw. So you need to use this one, then again this one. So para mo lang siyang dreno in a linear line. So depending dun sa change of curvature, dun ka maglalagay ng borehole location. Okay. Then how to prepare sample. Okay. So since na kunwari alam mo na yung boring number of bores, ano yung location, ano yung mga distances. So paano ba prepare yung sample? Okay, sample should be properly labeled and sealed to preserve moisture. Sample level should contain borehole number and test pit number or test pit number. You have the sample number, how many samples in each boreholes. You have this depth in which the sample is taken, the description of the sample, the date in which the sample was taken, and the name of person taking the sample. So the name of person taking the sample is only for the company, for company issues. Okay, the date in which the sample was taken, you need to always consider the date. So this is an example of a rock sample placed in a core or in a core box, or a soil sample, should be soil samples. What is happening? Okay, there should be soil samples placed in a core box. Okay, then we have these common sampling methods. We have the standard split spoon. We have this thin wall tube or Shelby tubes, nakalagay siya sa tube. And yung isa yung standard split spoon. Ibig sabihin hinahati yung tube in the middle, and sometimes they have this diameters 34.9 to 50.8 millimeters. And this one, yung thin wall tube, nandyan talaga siya, seamless, hindi siya nakahati. And we also have this rock coring. If again, yung last sample, yung last test boring, okay, the percussion drilling, percussion boring are able to determine to get the rock sample or the bedrock sample. So if necessary, when bedrock is encountered, you can use this core barrel that is attached to the drilling rod. So you can attach it to the drilling rod, okay, and take using the coring bit, attached to the bottom of your test boring machine. Okay, so you need to use the quality of the rock is obtained for evaluation and for rock quality designation. Okay, and also of this NSCP 2015 Foundation Investigation. Okay, the foundation investigation shall be conducted and a professional report shall be submitted at each building site. Take note, based on the building codes, for structure that is 2 stories or higher, an exhaustive geotechnical study shall be performed to evaluate the in situ soil parameters for the foundation. So in other words, if your building is 2-story or higher, you need to get a geotechnical report or geotechnical study in the site. Okay, so that is based on the building codes. However, some municipality are using 3-story up to require geotechnical report. However, if you check in the foundation investigation section 303 of the NSCP 2015, it should be 2-story or higher. Okay, so ibig sabihin every 2-story dapat nagpapa-provide kayo ng geotechnical report. Okay, and we also have the sample boring log. Okay, so for the sample boring log, you just need to indicate the soil profile of your sample. Let's say this one, shopping center. Then at the depth of 0.3 to 0.6 meters, your description of the soil is sandy silt. Okay, at the depth of 0.6 to 2.7, you have this description of the soil, and you determine the groundwater table at this time, June 14, 1997. Okay, so you need to consider this groundwater table. Take note that the groundwater table is increasing, sometimes decreasing. It depends. You have these many factors. Okay, then you have this soft clay at this location. Okay, then also have this compact sand and the end of boring at 6.4 meters. Then you need to indicate the liquid and the moisture content, the standard penetration number, the N60, and some additional comments for the, let's say this one, the Atterberg limits and the shear strengths of the soil. And we also have the sample geotechnical report. Kung makakakita na kayo ng sample ng geotechnical report, maybe in the future if you want to be a structural engineer. So this is a sample geotechnical report given to us. Okay, so the foundation solution is stated in the geotechnical report. Let's say this one. Okay, so the foundation solutions are given by the geotechnical engineer. So let's say the main highlight of this foundation solution is using a fixed allowable bearing capacity of 180. So therefore, we are using SBC to be 180. We need to design all our foundations at 180 kPa. Then we need to use this factor of safety of 2.5. Okay, so you need to use a factor of safety of 2.5. Okay, then also allowable settlement of 35 millimeters according to the geotechnical report. Okay, and sometimes they are given this foundation solution. Let's say the sample is liquefiable soils. Okay, this one. If you need to use a shallow foundation, or the geotechnical engineer say you cannot use you cannot use shallow foundations, you need to use deep foundations. So that is a geotechnical report. Okay, so for the reference of our discussion, this one. Okay, and that's it, class. So again, thank you for listening, and this is a subsoil surface exploration and the NCP 2015 provisions.